So good afternoon to one and all. As per the instructions given by the Training and Placement Office, is College of Engineering, Pandrapur, we are planning for the advanced technical training for all the final year students. Okay. So based on according to that, every Saturday we are going to conduct 2 hours lecture and half an hour or 1 hour test we are going to conduct. So as per the schedule prepared by your class coordinator, actually this class was previously only due to some problems we have not conducted. Today we are going to discuss about the subject, that is electrical measurement and instrumentation. We are going to discuss here. So this task is given by Training and Placement Officer. This task is given by TPO only, because why the advanced technical training is necessary for you people is nothing but the main we are concentrating on GATE exam. So to help you people, we have planned this training. Already you have studied in the second year, third year, you have studied the subject, but to give the touch up for that, we are not going to discuss complete in detail this one. Only in a short, to give the touch up of that one, we are recalling the knowledge of the electrical measurement and instrumentation subject. We are just recalling that one. So after seeing your participant list, I understood one thing, that as a TPO coordinator, I am not satisfied with your name. Whatever the name, display name you have used for the Zoom meeting, some people they have used 01 space their name, and some people they have used 05 dash their name, 08 there is no space at all, the name directly they have used. Some people they have used their roll number underscore, and so due to the internet connection problem in the college has been disconnected. Okay. Rule number 41. What I was telling, the name, display name should be unique. You are in final year. Other than these classes, other than your academic classes, you may attend some workshops, simulations, training center, even you may attend further training and placement activities. On that situation, we will not get who is this student, which branch it is, and all the things. आवाज आ रहा है क्या अभी? Is it audible? Is it audible or not? Okay. So for that reason, I am requesting you all that first you change the name now. How you should have to use the unique name. Unique name, according to me, the unique name I am suggesting you people that you can use. I'll write here only. Okay, you can use EE, all capital letters. There is no space at all. EE underscore. What is your class? BTech, na? Class which one? SY, TY? I will use B dot tech, or directly without any what is that one dot, you can use this one, BTech underscore your roll number. It should be 129, it should be 01209. Then your first name, middle name, and last name. First name, middle name, and last name. Will you join like this? EE underscore BTech underscore 01 means it is roll number underscore your first name, middle name, first name space middle name space last name. Will you join like this, all of you? I'm asking individually. So now time is 1:12. I will request you all the peoples, all of you know what you do. You leave the meeting. You change it by either ही change किया तो इधर ही rename किया तो सिर्फ only for this meeting it will change us. I'm not talking about this meeting only. For the future upcoming meetings also, your name should be unique. For that reason, all of you, you leave the meeting, go to your Zoom setting profile and change the name, then join again. The strength is not big. It is only 26 members are present. Leave the meeting, change, rename your profile, then join once again. We can conduct this activity, ATT activity, other class also, but this should be correct now. Roll number 2, 5, 15. $56 over. Roll number 8, Puja over. 57. He has submitted. Do it fast. Roll number 2, 5. You have to leave the meeting. Then only I will allow you to attend the class. Otherwise, I will remove. Once I remove means you will not be eligible to enter the meeting. मैंने खुद रिमूव किया ना, वापस ये पूरा क्लास होने तक आप कितना बार ट्राई किया तो भी वापस क्लास के अंदर एंटर नहीं हो सकते. Roll number 1, roll number 14. This is one of the most important requirement was there for the electrical department. You people should not follow the unity names. Unique names you are not going to follow. That was actually observed by so many faculty, staff members also, they have told to me. Okay, so this is the one thing you have to change. First one. Second one, for further any activities of the training placement activity, you should have to keep the proof with you peoples. Should have to keep the proof. So once the message came from me, then immediately you have to do the registration. For any activity, you should have to do the registration related thing. So we'll start the ATT class now, and later another last 10 minutes or so we can discuss about the training placement activities. Okay, so as per the instruction from the training placement activity only, we are conducting the advanced technical training for you peoples on the subject that is called electrical measurement and instrumentation. So the syllabus, and already we have conducted the classes based on this one only. The measurement of voltage, current, power factor, and the bridges, potentiometer, IT, instrumentation transformer. Instrument transformers is nothing but CT, PT, digital voltmeters, multimeters. By using the CRO, we can measure the phase, time, and frequency measurement. Some oscilloscopes are there. So everything, this much syllabus is important for the gate. Okay, you have so many 6 units are there. Out of 6 units, everything is not important. Related to the previously asked question paper, which one is similar, that one we are going to discuss here now. So the questions and all the things in the vacation, during the vacation, we have discussed already. So first point, to measurement of voltage, current, power, energy measurement here. Can you tell me to measure the actually voltage, current, power, mainly the second unit of the measurement and instrumentation, the measurement of instruments classification we have to discuss. In these classifications, Some instruments we have derived, we have classified. Those are first one, which instrument which will indicate the value, that is called indicating instrument, recording instrument, indicating instrument, sorry, integrating instruments. These three types of instruments are there. So out of these three instruments, which one we are going to use, which one we have studied, on which, what is the operation, how many forces are there, that one we are going to discuss in the today class here. So the measuring instruments can be classified into three types, that is called indicating instruments, recording instruments, and integrating instruments. We are going to call that one. Before this one, basic instruments, primary instruments, and absolute instruments, that one no need to discuss. Directly I am going indicating instruments and recording instruments. So the name itself, it is saying that indicating. Indicating means one pointer is the that pointer, it is going to indicate the particular value, that is the measurand or measuring value, we can call that one here. This instrument uses a dial and a pointer to determine the value of measuring quantity here. Now, which quantity we have to measure, what is that quantity, that one, the magnitude of that quantity will be indicated by this dial or pointer. It is going to indicate somewhere here. Now, which value it is going to stop over there, that is the our measuring quantity or the magnitude of the measuring quantity, we can call that one. So the pointer indication gives the magnitude of the measuring quantity. Where the pointer it is going to indicate, that is nothing but our magnitude of the measuring quantity, we can say that magnitude of the measuring quantity. Next, the second one, recording instrument, is this type of instruments, it is going to record that one. It is going to record whatever it will not count that one, how much incoming, outgoing, or whatever it may be. Presently at this time, today 4th December, how much voltage was there at 12 p.m. That's it. It is going to record here. It is going to record. So many people, you are not understanding the recording instrument and in the integrating instrument. This type of instruments record the magnitude of the quantity to be measured continuously over a specified period of time. For a specified period of time, for 12 p.m., 1 p.m. of every 1 hour, we have to measure that one. It should have to record that value. 12 ko kitna tha, how much was the voltage? For the 1 p.m., how much was the voltage? 2 p.m., 3 p.m. So why the recording instruments are required means, especially for the peak load, we are going to call here. Now in a industry it is different, but in the residential houses and all the things, the peak load is morning time and evening time. Because in the morning time, everyone will be hurry to go for the work in a city, especially in the cities we are talking about now. So they are going to switch on the grinder, mixer, washing machine, fridge, everything will be switched on in the morning time, geyser. Yes, on that situation, it should be high up to 10 p.m., 10 a.m. that is. And evening 6. So much disturbance in the internet connection. So it is fluctuating in nature. For that reason, automatically it is disconnecting. Who has admitted Mangesh Narkar? How you entered the meeting? Neha Bhosle. Bhosle Neha, is it audible to you? Or not joined the audio? I'll put you in again waiting room only. Change the name as per the instruction given by me. Otherwise, you should be waiting in the waiting room only. Mangesh, Narkar Mangesh, is it audible? Narkar Mangesh, what is your roll number? Will not tell the roll number, will not get the attendance. See now how it is looking actually. You only click on the participants, you can check that one. This is the actually We have to show the unity or unique departmental activities actually. Okay, so there is a lot of difference is there for recording instruments and integrating instruments. So the recording instrument, just for a particular time or specific period, they are going to record the value. They are going to record the value. But with respect to time, that is integrating devices we are going to consider. See here, the display name is the here L1, line 1, line 2, line 3. The line 1 voltage, line 2 voltage, line 3 voltage. It is going to measure for every 1 hour, every second also you can record. Every 1 minute, every 5 minutes, every hour, every day, every week, every month, every year also we can record this one. Depending on the specific period of time, we can record this one for the 24 hours, for a month, for a year, like that we can record this one. So name itself, it indicates that recording instruments means they are going to record the values or magnitude of the instrument. They are going to just record that one. Okay. Next, the integrating instrument, this type of instrument gives the total amount of quantity here. Now, how much quantity to be measured here now over a specified period of time. Over a specified period of time. Here, the integrating instruments means particular for 1 month, how much consumption of energy we have used. That is, also we can consumption energy meter. For the generation also, how much we have generated for 1 month, we can calculate here. The best example I can give, in your house, suppose anyone, you can consider in your pocket or in your account, you have 10,000 rupees for the December 1st. Okay. So every day I will use a recording instrument. I am going to count that one every day. And for the every day, how much quantity the change it is, which I have to record that one here. December 1st 10,000 था. Suppose आपका friend में आपको 5,000 रुपए देना था, वो 5,000 रुपए दे दी. How much it is there for the December 5? So December 4 today. पहला कितना था? 10,000. Now 10,000 plus 500, how much it is? 15,000. The 15,000. So December 4th, recording instrument will record that one 15,000. Next, after that one, at the 6th December, you will get the salary of 40,000. You can add that. 40,000 rupees salary is added. So that 40,000 plus 15,000 for December 6th, the recording instrument, it is going to record that it. 15 plus 40, how much it is now? 55,000. Total 55,000, it is just recording that. But the integrating instruments, our aim is to how much consumption, means the we can in the salary we are amount we are considering, means whatever the expenditure we can calculate or whatever the income we can calculate here now. Previous, what is the total amount? Previous amount 10,000. What is the extra amount? 55 minus 10, how much it is now? Present reading minus old reading. 55 minus 10,000, how much it is? 45,000. That is called 45,000 is the difference. We can call that one as income here now. Like that, the integrating instruments initial value or final value minus initial value for a month, for a week, for a day, we can calculate over there. So particularly if energy meter, it is going to view the consumption. If we are generating, means that generating energy meter, generation energy meter, we can use that one initial value or present value and final value we can consider like that. Difference, barabar, understand? All of you? Difference, have you understood? The integrating and the recording instrument. Yes, any doubts? Someone is unmuted. Okay. So these are the three type of instruments are there. So this type, this instrument, we can discuss. We are already recording instruments we can discuss. But the principle, all the principle of the indicating instruments, the syllabus, they have added more. Based on that, we are going to discuss the first part, that is called indicating instruments here. You have done machine practical. Have you done, all of you, machine practical? Have you done? Presently we are doing IDC practical. Yes, in a machine practical, any one person, you can unmute and you can reply. Which instrument you have used in a machine practical to measure the voltage and current? Indicating instruments or recording instruments? Wattmeter and all the things. Any one of you? You have already performed the practical. Indicating instruments you have used. So the indicating instrument you are using, then you should know the what is the essential for indicating, how it is going to operate, what is the controlling, how we have to damp that, whatever the oscillations are there, everything you should have to know over there. So some essentials are there for the indicating instruments. So those essential things we are going to discuss in the today's session. The indicating instruments are those which indicate the value of the quantity. That quantity it is going to indicate that one. Especially the indicating instrument, it has three characteristics it has here. Suppose this one you can consider as a, this scale you can consider this one, dial or scale, you can consider this one. Here the pointer is there, here the pointer is there, here the pointer is there. To rotate the pointer, what is the needed here? No, the pointer should, we are going to measure, means the pointer should have to move here from 0 to non-zero value. Yes, from the, to operate the meter, the pointer should have to move from 0 value to the whatever the measuring quantity is there here. This one 0 I am going to consider. Suppose this one has 10 ammeter we are going to use, you consider that one, DC ammeter we are going to use here. From 0 to some value to indicate that one, the pointer should have to deflect here. The pointer should have to deflect or not? So in your class, I understood there is no interaction then, only one way. सिंपली एक्सप्लेन करते जाने का, आप चुपचाप मीटिंग ज्वाइन करके सो जाते हैं, खाना करके, दोपहर का टाइम हो गया कैसे भी. यस, आई एम थिंकिंग लाइक दैट ओनली नाउ. इज इट करेक्ट और एनीबडी लिसनिंग द क्लास? If you people, nobody is replying, means that is true only. What I am saying, that is true only. You people are busy in your work. Sonal, rule number 18.
Yes, sir.
Okay, you are alert now. Kiran Rokde. Rokde Kiran. Dongre Mahesh. Mahesh Dongre. इधर तो बिजी है ये लोग. No use then. I will not ask that. Then only explaining part means okay. Then I have added some 20-25 MCQs also. On that situation, you have to give the answer for that one. If nobody will give the answer, means how the session should be interactive. No problem. So this is the instrument. The instrument, to operate the instrument, the operating force is required. That operating force we are going to call as deflecting force. So once it is operated, to come back to the original position, that is, it should have to restore the value, or the pointer should have come back to the original position. The torque required, that torque is nothing but restoring torque or restoring force, you can call that one. It is nothing but controlling force, you can call that one. Torque is nothing but force only. Controlling torque or force, you can call that one here. in between this controlling and operating and restoring torque, what will happen? One, the force they are going to, if two persons are fighting, to silent, to make that to make them to both of them to silent, one more torque is required, that is called damping torque. We are going to call that. The deflecting torque, operating torque, it will try to operate. The restoring torque, it will try to restore. In between, what will happen? The exact value, it is not going to meet over there. There it is going to fluctuate over there. So that oscillations will occur over there. To mitigate that oscillation, the damping is required. The torque required to damp these oscillations, that is called damping torque. We are going to call it. So the moving system, whatever the indicating instruments, it should have three essentials are there. One is the deflecting torque, another one is controlling torque, and third one is damping torque here. So this one I know, I think you people are studied in the second year very well and you have understood everything. I am not going to go much more details about that one. So here again the explanation is there. There is again the screen is visible or not?
No, sir.
It is not visible, huh?
Now visible.
इसका पहले विजिबल नहीं था क्या? कोई तो बोलना है ना फिर. अभी बोल रहे थे. Okay, we'll keep like this. Is it visible now? Yes.
Yes, sir.
Okay. So the essential of indicating instruments is nothing but three forces are required. That is deflecting or operating torque, controlling torque, and damping torque here. So next we'll go. That is, what do you mean by deflecting force? Deflecting force means what we are going to discuss here now. Deflecting force means whatever there. So the initial, what is the meter is at 0 values over there. Okay. See here, this is the ammeter. You just think that one. This is the scale or dial. We can think that one. And the pointer will be like this here. This is the spindle is there and which is attached to the pointer over there. Okay. Here the points are there here now. The magnitude or the values I have written in the scale over there. The values I have written here now. So to operate this one from 0 value to non-zero value, it's the pointer should have to move here now. It should nothing but it should have to deflect here now. It should have to operate this one. So for that reason, we are going to, the force required is operating force or deflection required, deflecting force we are going to call that. If there is no input, then the instrument will be, the pointer will be at 0 only. But we have given some supply, we have provided input, then the pointer will start to deflect from its 0 value to the non-zero value. That force is there, that force to deflect the pointer is there. That is called deflecting force or control operating force we are going to call that. To deflect the pointer from its 0 position, a force is required or necessary, which is known as deflecting force we are going to call. To create this deflecting force, one system is there. That system we are going to call as deflecting system we are going to call that. This deflection, it may be occur because of the heating also, it may occur because of the chemical action it can occur, this deflection, or because of the magnetic, electromagnetic induced, electrostatic. For anything, the deflection may occur over here. The deflection, if the heat is increased, also some heat sensitive elements, by using that one we can move this deflection, the pointer can move on there. So the deflecting torque is produced by making one of the magnetic, heating, chemical, and electromagnetic induction effect of current or voltage and cause the moving system instrument to move from its 0 value to position here. 0 value position, you can move that one. The system which produces the deflecting force is known as deflecting system we are going to call. Generally, deflecting system is nothing but it converts electrical signal to the mechanical force. So any indicating instruments, you have used the emitter. Emitter use kiya na all of you? Yes, all of you have used the emitter. So input, what we are going to do for the emitter? Supply we are going to give one positive terminal, negative terminal we are going to give the supply. So supply is nothing but it is electrical energy is provided here. But because of this supply, what will happen? The pointer, the element or this pointer, the hardware, it is going to move over here from 0 to non-zero value, it is going to move. So some mechanical work is done here. So for that reason, what we are going to call electrical signal is converted into mechanical force here. Now, given is input electrical signal we have given, but the output is the deflection occurs. So mechanical force is created over there. We can call that one. So this is nothing but deflecting force we have called here. Now this is the pointer, same thing I have told. Initially this pointer was here, it is deflected to the non-zero positions over there. So once the pointer is deflected or operated by operating force, so after removing once the electrical signal is given, then the pointer will deflect, it will go to the particular indicating the quantity or magnitude of the measuring quantity, it will indicate and it will stop over there. But after removing the supply, the pointer will come back to the zero or it will stay over there only. It should have to come back to zero or it should have to stay over there only. Yes? Anybody? Anyone? Can you reply? No way. Okay. So the controlling force is nothing but once the pointer is deflected, then the deflected pointer is nothing but because of the operating force, it is deflected from zero value to the non-zero value here. Zero value to the non-zero value, it is has deflected from here to here. But after removing the supply, it should have to come back to the zero. Then only we can say that one, the indicated value, it will come back to the zero. Once the again we have to give the signal, it is going to measure over there. So the deflected force is created, the pointer is moved from zero to non-zero value. So because of the force is required to bring back the pointer to the original position or zero position, some force is required. That force we are going to call as controlling force, we are going to call that. That's nothing but controlling torque or controlling force is required. It will bring back the pointer to the zero position. Bring back to the pointer to zero position over there. So all of you know the balloon. You know the balloon. All of you played in your childhood or in your house. If your child is there, they will fill the air into the balloon and he will just hit that one, means it will go, some work will be done over there. Okay, by touching that one, that is called deflected over there. But once it is touched, it will not come back. It will not come back. It will go. It is deflected over there. So deflecting force. But that balloon is tied with some rubber. If you hit that one, again it will come back to you only. I think you have played that game also. Yes. इतना फ्रेंडली बोल दिया तो भी तुम लोग एग्जांपल दिया तो भी रिप्लाई नहीं दे रहे तो you people are interested to listen the class or not? I am not getting that one. Simply listening, it is not use. घर में खाना बना रहे, उसको देखा तो पेट भरते क्या है? खाना बनाने वाले के देखते बैठे तो पेट भरते क्या? You have to eat, you have to interact, you have to study, you try to give the answer, then only it will helpful, you will get the knowledge to you. Otherwise very difficult, I am telling now only. Okay, so that is called to bring back the pointer into zero position. The force is required. That force we are going to call as controlling force we are going to call here now. To make the measurement indicated, which one is visible here now? Screen. Controlling force is visible.
Yes, sir. Yes.
One more PPT was also displaying. Okay. So to make the measurement indicated by pointer constant force is necessary, which will be acting in opposite direction to the deflecting torque. So from this one we can say that one, because of the deflecting torque, 0 to non-zero value, this much quantity it has detected. But once because of the controlling torque, it will bring back to 0. Here we can call that one deflecting torque equal to controlling torque. Yes, the value deflecting torque is equal to controlling torque we can call. How much is the deflection is same only, na? From here to here, it will go operating torque. This will be restoring torque here. No, both are same only, but direction is opposite. The magnitude is same, but opposite in direction both we are going to call that one. It is necessary, which will the force is known as controlling force. The system, whatever the system which will produce us this bringing back the pointer, that is controlling force, that system we are going to call as controlling system. We are going to call the function of controlling system is to produce the force equal and opposite to the deflecting force. See here, this is word is very interesting. Equal and opposite to the deflecting force. Just a minute, someone has logged out. Okay. This, the main aim of the controlling system is to produce a force which is equal and opposite to the deflecting torque. The value should be equal, but the direction should be opposite here. Now add the final steady position of a pointer in order to make the deflection of that one here now. And one more function is to bring the moving system back to 0 when the external signal to be measured by instrument is removed. If the supply is removed, it should have to come back to the 0 and it should have to settle at the 0 or instant constant value or initial value, we can call that one here now. To do these two functions, the main controlling system is required. The main controlling system is required to do the performance of these duties here now. Next one, there are spring controls we are going to use here now. The torque producer controlling torque is nothing but TC equal to theta. Controlling torque is TC, we are going to call. Whatever the deflection is, the deflection called theta, we are going to call here now. So that same here, two springs they have used for the movement of that one. The third force, that is called damping, we are going to call it. That is very important. Damping. Damping is required. What do you mean by damping force? Anyone? Can you give the real-time example? Any one of you? Here, I will give the best example for that one. See, because of the deflecting force, it is going to deflect here, no? Because of the controlling force, it is going to control here, no? In between, what will happen? Both the forces are produced in the same system. Because of the deflecting force, the pointer will go away, and because of the controlling force, it will bring back here now. So it will not settle. The settle point, it will take time to settle at a particular value here. To avoid this one, we have to add the damping force. पहला damping force means आपको बहुत सारे लोगों को मालूम नहीं शायद. I think I'll clarify. The best example for that one is, okay, now we can give all of you. घर के बाजू एक पेड़ रहते हैं, उसका ट्री ब्रांच, I will tell that one. So इसका पत्ता निकलने के लिए हाथ डालते हैं, मालूम है क्या? ये अभी तो रिप्लाई करो. I am speaking in Hindi only. If you hold the tree branch, okay, it will come towards to you. When you will hold that one, उसको खींच लिया तो आपके सामने आ जाते. Then you leave that branch. Suddenly it will go up. Original position को नहीं थे, up हो जाएगा, फिर down हो जाएगा, up and down. It will take some time to settle down. Yes or no?
Yes, sir.
That is called fluctuation. We are going to call here, or oscillation. The fluctuation किसके लिए हो रहा है? उसको फोर्स नहीं, कंट्रोलिंग फोर्स नहीं है. उसके लिए क्या करो आप, वो ट्री ब्रांच को थोड़ा वेट ऐड करके हाथ छोड़ दिया ना, वो it will not take much time to settle. Time ज़्यादा लेते क्या वो settle होने के लिए? So deflecting it will take slowly, it will settle over there. Like that, we have to add a force here now in between this control deflecting force and controlling force. It will not settle, the pointer will not settle that one. It will go away that behind that value and it towards the initial value. Like that, it will start to fluctuate here now, and it will take some time to settle here now. It will not give the exact value for the instant time. For that reason, we have to add the eddy current, or sorry, damping force we have to add in the instrument, measuring instrument. Then it will damp, and slowly what it will do, the pointer will slowly move to the particular value and it will stop over there. It will stops over there if the damping force is there. That may be the damping force, maybe it may be we can add the weight, we can add that one, or some eddy current damping is there. So many different damping forces, damping methods are there. We can add that one. Is it clear? Damping force. See here, this one I will explain that one here. See here. So our aim is to, the pointer should be have to settle here. The pointer should have to settle here only. A and 2 terminals are there. Okay, because of the deflecting force, the pointer will go away that one behind the steady value. This is the steady value we are going to call. Because of the controlling force, it will go back to here. Like that, it will take some time. Either say idhar jayega, then from here to here, then from here to here. Like that, it is going to move over there only. Slowly, it will reduces its length, high, whatever the deflection is there, it will reduces, and after some time it will settle at this point here. So this is fluctuation is occurring here. Now there is no constant value of movement. To avoid this one, the pointer should have to go to the steady, final steady state value. For that reason, the damping force is required here now. So that is whatever the oscillations are there, that oscillations are, we have to oscillate the what is that one we are going to call, damp the oscillations, we can call that one. Is it clear? These 3 points are, forces are very important. That is for the operating purpose, operating torque, that is nothing but deflecting torque is required. For the restoring purpose, that is the torque required is restoring torque or controlling torque is required. For in between this operating and restoring torque, some pointer fluctuation is there. To avoid that one, damping torque or damping force is required. These 3 are the very basic points for the measuring instruments or indicating. So many questions will comes on this one. Is it clear?
Yes, sir.
स्टडी किए क्या इतना? चल करे पायल, ठीक है. Next, so mainly 3 instruments we are going to discuss, that is PMMC. Yes, PMMC, and one more, which one it is? Nothing but PMMI and EMMC. Have you heard the name? This PMMC, have you heard the name? Yes? Heard the name or not? I'm asking in detail. 162 slides are there. I'm not going to explain that much. Just I'm going to give the brief about that one. PMMC, have you heard the name?
Yes.
Yes.
Okay,
Yes,
what do you
sir.
mean by PMMC? Anyone, can you tell me?
Permanent magnet moving coil.
Okay, here only I have mentioned that permanent magnet moving coil, that is called PMMC. I have mentioned here. Okay, so what purpose to measure what we are going to use the PMMC? From using the PMMC, what we can measure? Anyone, can you tell me? By using the PMMC, we can measure what voltage, current, power, energy, power factor, frequency, what you can measure? That you don't know. Yes, we have already studied this one. Permanent magnet moving coil. By keeping the two magnetic in between two magnetic field, one moving coil, we are going to keep that one. So in the magnetic field, a current carrying conductor or coil is kept, means the force will be produced. Based on that force, the moving coil will rotate and it will going to indicate the value over there. So that indicated value, it may be voltage or current. Voltage or current. Yes or no? So PMMC, it is going to use to measure only voltage and current only. So later on we can use for other things, but the basic things we use it for voltage and measuring the current here now. So again I have a question: which voltage, which current? AC, DC, or both? Tell me. PMMC is used for AC measurement, DC measurement, and both AC and DC.
AC measurement.
DC or both? Remember.
Both.
Both. Here one option, here one option. Other people's? You can give an answer in the poll now. Anyone, you can tell the answers. DC or AC or both? Yes.
DC.
DC only. Very good. All of you. Some people, they have told, oh, nobody is mentioning the AC. It is not going to use for the AC. Nobody is mentioning the AC. AC के लिए use नहीं होता क्या PMMC? No, it is not going to use it for AC. It is applicable only for the DC, because if who know the operating principle of this PMMC, they can give the answer of this one here. See here, this is the two magnetic fields are there here. So by providing the positive negative supply here, it will create one type of one direction. The force is in between a magnetic field. The flux will be producers here now in one direction. Okay, in between this magnetic field, we are going to keep the moving coil. The force will be producers here now. Because of that force, this moving coil will start to rotate here now, which is connected to the spindle. The spindle is connected to the pivot, we are going to call, through a bearings, and the spindle is connected to the pointer here now. Once the pointer will spin, the moving coil will rotate, it will start to rotate. If I have changed the positive negative direction reverse, then it will start to rotate in opposite direction. The force direction will be changes or not? Yes. The positive direction, if I changed that one, the direction will change. The pointer where the stopper is there, at the end we are going to use the stopper. This stopper cannot stop the pointer or moving coil here now, because for that reason, it is not going to operate for the reverse direction. Positive polarity, the polarity should be main here now. Our aim is to DC. By providing the DC positive and negative, continuously it can operate. But the AC is nothing but alternating in nature. For the positive half cycle, negative half cycle, here it is going to oppose each other, and it will not operate, or it is not applicable for the AC. It is not applicable. It is applicable only for the DC, that too voltage and current we can measure here. Is it clear? Concept is clear? Yes?
Yes, sir.
So one more question I am going to ask. This torque equation and all the things, just now I have told TC is directly proportional to TD. TC is nothing but controlling torque. TD is nothing but deflecting torque. So TC is nothing but whatever the deflection is there. So the deflecting torque, I am telling that from non-zero, zero to non-zero value, the pointer move हो रहा है बोल के दिखा रहा हूँ, बोल रहा हूँ मैंने. Because of what it is going move? Because of the current in a coil. Yes, because of the current in a coil only it is deflecting. Yes. So TD equal to I, we can call that one TD equal to I, because of the current the deflecting torque is producing, because of the what is that, whatever the maximum value to this zero it will go, that is called deflection. We are going to call that one. This deflection or whatever the what is called, that is angle of deflection is there, it is because of the controlling torque, it is going back to the zero. So TC equal to theta, we can call that one. So indirectly we know the formula of TC equal to TD. So we can say that theta is directly proportional to I. Theta is the deflection is directly proportional to the current here now. So the scale, whatever the deflection is there, that much current we can call that one here. Now the scale is uniform. That is the one big advantage of this instrument here. Theta is directly proportional to I. It indicates that one scale is uniform. Whatever the I 1 ampere है तो इधर 1 point deflection हो जाएगा. 2 ampere means it is 2 points. It is going to deflect here. Now the scale is uniform. We can call that one here. And one more I have to discuss. Suppose I want to extend the range of the ammeter. Here PMMC we can use as a ammeter and voltmeter. This side I will use as ammeter. Here I will write as voltmeter here. So here I have some meter I have here now, that is called, it has the resistance, meter resistance, that is called RM is there, and here the meter I have connected here. So to meet this meter ammeter, I will give the supply here. Now DC supply I will give here and I will bring back to negative supply here. So up to 5 ampere only we can measure, but I have given 10 ampere supply. The total current is 10. How can I extend the range of this meter? Is there any possibility to extend the range? Is there any possibility to extend the range? Yes. Yes. How much current is there? 10 is there. How much the meter can take? Only 5 ampere take. Another 5 ampere by adding some cent is nothing but known resistance in parallel with the meter, we can bypass this 5 ampere current here. Now here 5 ampere, here 5 ampere, we can bypass that one. That is called cents we are going to call here. Now for the ammeter, to extend the range of voltmeter, we have to use the multipliers. Multipliers are nothing but in series we have to add one large resistance, external resistance, that will, with the maximum voltage drop will be, it is going to consume here. Now excess whatever the voltage is there, it is going to drop at that resistance here. So multiplication factor we have to calculate. By multiplication factor, that multiplication factor, we can extend the range of this PMMC by adding one resistance. For the ammeter we can add in parallel, for the voltmeter we can add in series with that one. So those concepts we are going to call that one as multipliers, cents and multipliers. Cents and multipliers, we are going to call that one. I have taken here some, I think, yes, CS, extension of range of PMFC. The cent one we are going to use here. Now see here, the current flowing through the meter is nothing but IM I have used, and the resistance, it has some meter resistance, that is called RM we have used here. Now so in parallel with this ammeter, we have connected one parallel path we have created, that is RSS, some resistance we have added here. Now so whatever the excess current is there, we are bypassing here. Can take 5 ampere meter rating. After that one, we can, so one small value of resistance we can add here. Now we can, all the current will bypass over there. If the high resistance we are using or low resistance we are going to use, anyone can you give the answer? Can use the high value of resistance or low value of the resistance? This one. Yes, anybody? Nobody. Nobody is ready to give the answer. Don't ask the question like that you are telling. Yes. But my aim is to, it should be interactive. Then only we'll understand that one. Okay, nothing to worry about that one. According to the Kirchhoff current law, current meeting at a point or a junction should be equal. Okay. So incoming currents are considered as positive, outgoing currents are considered as negative, like that. Or algebraic sum of the currents meeting at a point or a junction is equal to 0. Algebraic sum is means sign conventions we have to use here now. So according to this, the point P we are considering at applying KCL at this point, the current coming towards here is nothing but I. And how many currents are going? ISH and IM. They are going away from the point. So IM plus ISH, we can get that one. I equal to IM plus ISH. But the voltage here is same only. The voltage is V equal to VM equal to VSH. So IM equal to, you can call that one V by RM, we can call that one. And ISH equal to V by RSH, we can call that one. So we can calculate the multiplication factor here. Now the equation in the place of I, we can call that one here I by IM we have considered here now. By considering this one, we will get the last equation we are going to get here now. So I equal to IM, total current we have to measure. So IM is nothing but meter, it is going to display the value of this one, and into multiplication factor is 1 plus RM. Meter resistance is how much, and whatever the added resistance, how we can add the resistance, that value if you know that one, we can extend the range of the whatever the ammeter here. So this 1 plus RM by RSH is the multiplication factor for the measure ammeter here now, to measure the current here now. So shunt resistance is made of manganese material we are going to use. This has least thermoelectric EMF here now. So change is resistance due to change in temperature is negligible. Because the temperature is changing means resistance will also change. For that reason, we are going to use this type of methods. We are going to use the extend the range of ammeter here. Is it clear? Similarly, in a similar manner, we can use the multiplier by adding one large resistance in series with the meter. We can increase the range of voltmeter here. No, maximum voltage drop will occur at this resistance. So on that situation, whatever the meter rating is there, that one you can consider here now. So based on this one, in the ammeter we have used Kirchhoff current law, but in the voltmeter here can use the Kirchhoff voltage law we are going to use here now. So V equal to Vm plus Vsc, we can say that one. So based on that one, applying KVL, V equal to Vm plus Vsc. After applying the Ohm's law here now, we are going to get the final equation that is called V equal to Vm into 1 plus RSC by RM. 1 plus RSC by RM is the multiplication factor. This Vm is nothing but whatever the display meter will display that value here now. So by using the small range of suppose 100 volt rating voltmeter, by using that one, we can measure the 1000 volt also. We can measure 1000 volt also. So that is the method of PMMC, which is used only for the DC. It will not flow the reverse current because opposite direction the force will be produced. For that reason, it is not applicable for AC. It is applicable only for the DC. It is applicable, and we can extend the range of the meters also here. Is it clear? This is called PMMC. We are going to call that one PMMC. The time now. Okay. So permanent magnet, moving coil, some advantages and disadvantages they have mentioned here now. The torque weight ratio is high, power consumption is very less, scale is uniform. Uniform is nothing but theta is directly proportional to I. Damping is very effective, means it is slowly it will take and it will lead to the particular value. Since operating field is very strong, because in between magnetic field, electromagnetic field is there, so operating field will be strong. The effect of stray field is negligible. So whatever the storage is there in magnetic field will be stored. That stray means storage. So some field or flux will be stored. That is negligible. We are going to call that one. A single instrument may be used here now. Only एक instrument we can use for many different current and voltage ranges here. We can use for the 5 volts or 10 volts, 100 volts, like that. You can different voltage ranges and different current ranges also we can use for the different values for using shunts and multipliers here. So it completes the PMMC. Next, which one we have to discuss, that is called moving iron type instruments. Permanent magnet moving iron, we are going to call that one here. The PMMI is nothing but permanent magnet moving iron instruments. These instruments are applicable for both AC and DC. These instruments are applicable for both AC and DC, but only for the voltage and current we can measure here also. And some two types of moving iron type instruments are there. Moving iron type, main moving iron instruments are classified into two types: attraction type and repulsion type. All of you know that when if two magnets are there, they will opposite poles attract each other. South and north poles, they are going to attract each other. If north and north same poles repel each other, means it is going to repulsion will takes place. The main principle or functions of the magnet is two: attraction and repulsion here. No, based on that, if the two magnets are both the poles are opposite, then it is going to attraction. Though attraction means it should have to, one is permanent, another one is moving, we are going to use here. No, that moving will bring to the permanent one. So attraction, because of this attraction type, we have called that one. And but whatever the mechanical force will be produced to attract that one, that because of that force, the meter it is going to display the value. If the both the poles are same, then it will repel each other. One here, this is permanent we are using here. Now suddenly the poles will be created and it will supply is given, then it is going to repel, means it is going to move away that one here. On that situation, the moving coil, moving iron is there here. No, iron we have used, that iron it is attached to the pointer. That pointer is going to deflect here. Actually, this repulsion type is again classified into two types, that is radial and coaxial. No, radially means it is going to rotate radially, and coaxial means in between this coaxial some holes and some angles we have provided, in that one it is going to rotate over there. So the here also here, but the scale is not uniform for this one, because theta is directly proportional to square of the current we are going to call here, the square of the current here. Now the instrument can be used for both AC and DC measurements. We can use moving iron instrument. As the torque to weight ratio is high here, the name itself it is indicating iron here. Now remember that one here. There are no current carrying parts here inside that rotating part. Current carrying parts in nahi hai, kyunki iron we are using over there. So extremely rugged and reliable they are, and the losses are less. They have can call that one. These can withstand large loads and not damaged even under severe overload conditions. So they are not going to damage, because there is no winding at all here. Now in the iron, moving part is iron. So iron, it doesn't have the worry to about that one. The current will be increased, the heat temperature will increase, it will, the coil will burn like that. Okay. The range of instrument can be extended by using cents and multipliers. We can extend here also. Somewhere they have mentioned here, no, scale is not uniform. Is there anywhere? The scale of here only, the scale of the moving iron instrument is not uniform or is cramped to the lower end. Means here the formula itself we are going to get theta equal, theta is directly proportional to the I square. Whatever the current, the square of the current is applied, then 1 point here now. So if the I square 2 square is there here now, 2 square, then it will value will be detected here now, 2 points. 2 points it is moved here, means the current of that will become square here now, 4 it will become. So scale is not uniform, we can call that one. There is a serious error due to the iron part we are using, means hysteresis will be effect over there. So serious errors will be occurs there over there. So there is a difference between AC and DC. Calibration का purpose के लिए AC के लिए अलग करना पड़ेगा, DC के लिए अलग करना पड़ेगा. These are the some disadvantages of the moving iron instruments are there. The next one, next instrument is EMMC. I told that one is nothing but electromagnetic moving coil instrument. It is also called as dynamometer. Have you heard the name or not? This dynamometer. Have you heard the name of dynamometer? All of you. नाम सुना है क्या?
Yes, sir.
What is the function of this one? For what purpose we are going to use this dynamometer? See here, the main function is same here. Now it is also applicable for both AC and DC. It is air cooled. There is no core at all. Only coil wound we are going to use here. One fixed coil and one moving coil is there. The fixed coil is made into two parts. This is half part is kept here. Another half part is kept here. In between these two, one moving coil is kept here now. So there is no core part, means air is act as a core here now. Air will be act as a core. It is applicable for both the DC and AC here now. Whatever the force direction is there, if the same current is flowing through the all the coils here now. See a current I, the half of the fixed coil it will flow here, next half of the it will flow, the magnetic field will produce us in between this half of the magnet fixed pole, the same current will be flow through the moving coil also, and it will go back here. So for the positive half cycle also same current direction is same in moving coil and fixed coil. For the negative half cycle, the current direction will be like this here now. So all the current direction will changes, all the current direction of, in the moving coil and fixed coil. So there is no worry about the position, because the current direction will be same, the force will be same for the all the polarities here now. So it is applicable for both AC as well as DC, it is applicable here now. But this instrument we can use for the three parameters, three electrical parameters we can measure, that is called voltage, current, and this electrodynamometer moving coil is nothing but EMMC, or dynamometer we can use for the measurement of power also. Wattmeter, have you heard the name wattmeter? That is dynamometer only, we can use as a wattmeter, we can use this one. So it is applicable for the voltage measurement, current measurement. We can measure voltage, current, power also here. No, have you heard the 2 wattmeter method, 3 wattmeter methods? Heard the name? Methods. 2 wattmeter method, 3 wattmeter methods. We have already studied that one. By using a 2 wattmeter, we can measure the 3-phase powers. सुना है क्या? भूल गए नाम? नाम सुना है क्या नहीं? Hello, is it audible?
Yes, sir.
Okay, so that one. So for the emitter connection, this one here, this is the half fixed coil, half fixed coil. In between moving coil, we have used here, and the one the external swamping resistance is nothing but this characteristics of swamping resistance is to reduce the temperature we are going to use. If the temperature increases, this resistance value will also increases. So resistance value increases means the current flowing through this one will be increases or decreases. Think करना है sir बोलते हैं अभी. If the resistance is increases, then what is the value of current? Current will be increases or decreases? I is directly proportional to R or inversely proportional to the R?
Inversely.
So I equal to V by R. If the V is constant, it is the current is inversely proportional to the resistance. So if the temperature is increased, then what will happen? The resistance value will be increases here. Because of increase in the resistance, the current will be decreases here. The temperature will come to the normal position. For that reason, the swamping resistance we are going to use here. Okay, so shunt resistance we have used here for the emitter connection. Just a minute. बोले. So this one emitter we can use the emitter connection, and some formulas are there. We can use the voltmeter also, we can connect, and even for the wattmeter also we can use the electrodynamometer, we can use as wattmeter also here. So for the objective questions, I have to make this one as slideshow only. Is it visible? The screen is visible?
Yes.
Can you read any one of you? What is that one? Objective questions. है क्या उसमें?
The average of deflecting.
Okay. The average of? Yes, read it.
Deflecting torque.
वो है क्या? एक मिनट, अभी ऑब्जेक्टिव क्वेश्चंस बोल के
हाँ है सर.
क्वेश्चन डिस्प्ले हो गए.
Yes sir.
Okay, an instrument in which the value of, just a minute, I will switch on the camera. Okay, now we can give the answer for this one. The instrument in which the value of electrical quantity to be measured can be determined from the deflection of the instrument when it has been pre-calibrated by comparison with an absolute instrument is known as. I told you absolute and primary institute, secondary institute starting is there. In that one, which one is used here now? An instrument in which the value of electrical quantity to be measured can be determined from the deflection of the instrument. Deflection से हमने measure करते हैं. That is not a problem. When it has been pre-calibrated by comparison with an absolute instrument is known as what? The options are absolute instrument, secondary instrument, a recording instrument, and integrating instrument. See, whatever the indicating instrument, recording instruments, so these secondary integrating instruments, these are all what, primary absolute instruments or secondary instruments? That much basic we have not gone. Okay, this answer I will tell that one. See here, mainly there are two instruments only, absolute instruments and secondary instruments only. This recording, integrating, and indicating instruments will come under this secondary instruments only. So the pre-calibration should be done by secondary instruments reading, we are going to call it. It has been pre-calibrated by comparison with the secondary value instruments is the correct answer here now. So the secondary instrument we are going to call that one. Next, question number 2. Question number 2 is visible. स्लाइड शो का थोड़ा डिफरेंस है, नहीं विजिबल नहीं हो रहे.
Not visible sir.
नॉट विजिबल ना, वही
First ही दिखाई दे रहा है सर.
हाँ, अभी श्रद्धा का आवाज आया. देखो इतना टाइम क्या कर रहे थे आप, खाना हो गया क्या नहीं?
सर मैं यही भी थी, यही भी तो थी ना सर. मैंने
आंसर तो नहीं दिया ना. ओके, अभी नाउ इट इज विजिबल.
Yes sir.
Okay, read the question then. Shraddha.
Damping torque in instruments is generally not produced.
Damping torque in instruments is generally not produced by, pneumatically it is not produced, or electromagnetically or electrostatically or fluid friction. This one also we have to study this basic question here. Numerically we can use that one. Okay, electromagnetically also we are producing that one. Electrostatically and by fluid friction, ये दोनों में कौन सा भी एक चूज कर.
Fluid friction.
फ्लूइड फ्रिक्शन में क्यों नहीं होते? फ्लूइड फ्रिक्शन मींस क्या होने वाला है? उसको फ्लूइड यूज करके हमने ऐड कर सकते हैं ना. द मेन इज इलेक्ट्रोस्टैटिकली. स्टैटिक यूज करके हमसे डैम्प कर सकते हैं क्या?
नहीं सर.
That is the question answer. Electrostatically we cannot damp torque in an instrument here. Now the answer is, correct answer is electrostatically it is not possible here. Now क्या करने का बोलो. अब ये क्वेश्चन तो आंसर देना है. तीसरा क्वेश्चन, थर्ड वन, इज विजिबल टू ऑल ऑफ यू? इज इट विजिबल?
Yes sir.
हाँ, Shraddha, read it.
A pointer of an instrument once deflected returns to zero position when the current is removed due to
what action of gravity, mass of pointer, controlling torque, damping torque, deflecting torque? Anyone can you give the answer? Any one of you can give the answer. Yes, Payal.
Controlling torque.
कंट्रोलिंग टॉर्क.
Yes.
कंट्रोलिंग टॉर्क से हमने जीरो जाते क्या वो? A pointer of an instrument once deflected, already it is deflected, okay, returns to zero position when current is removed. Supply remove करने के बाद the pointer should have to go back to the zero position because of what? Action of gravity हो सकते, mass of pointer we can add the weight add किया तो उसके वजह से हो सकते, controlling torque की वजह से हो सकते, damping torque की वजह से हो सकते. Which one is the correct answer? I want to the in majority. One person told ये तो नहीं. Shraddha, you only tell the answer.
Mass of the pointer.
Which one? Mass of the pointer. उसको mass pointer add किया तो उसकी वजह से होते क्या? Mass means weight. If we have add the weight, then it will take that one. इतना वो एक्सप्लेन किए मैंने बोल दिया है जीरो से नॉन जीरो वैल्यू जाने के लिए डिफ्लेक्टिंग टॉर्क चाहिए. वो सप्लाई रिमूव किए तो वापस जाने के लिए कौन सा टॉर्क चाहिए? कंट्रोलिंग टॉर्क चाहिए बोल के इतना बोलने के बाद भी ऑप्शन एक ही बोल दिए वो भी स्टार्टिंग. द करेक्ट आंसर इज कंट्रोलिंग टॉर्क ओनली. एक बार डिफ्लेक्ट हो गए उसको वापस जीरो के लाने के लिए सप्लाई रिमूव किया तो जीरो कैसे आ जाएगा वो? बिकॉज ऑफ कंट्रोलिंग टॉर्क ओनली. स्प्रिंग कंट्रोल मेथड वी आर गोइंग टू यूज ओवर देयर. अभी इतना सबको आंसर भी दिखाया. ये लास्ट क्वेश्चन है. यू कैन टेल द आंसर ऑफ दिस वन. एन एमीटर. Emitter means what? Is inserted in series in a circuit and current to be measured flow through it here. An emitter is inserted in a circuit and current to be measured flow through it. Pehla option. Second one, an emitter is inserted in series in a circuit and part of the current to be measured flows through it. Third one, an emitter is connected in parallel in a circuit and current to be measured flow through it. Fourth option, an emitter is connected in parallel in a circuit and only part of the current to be measured flows through it. Tell the correct answer. This is the last one.
सर सिरीज मध्ये इन्सर्ट केल्या.
दो ऑप्शन है उसमें सीरीज में इंसर्ट करने के लिए. एमीटर को सीरीज में करते क्या पैरेलल में करते?
सिरीज.
देखो ध्यान से देखो. हाँ, yes, which option you are agreeing then?
Yes sir.
Yeah, very good, very good, very good, very good. Your answer is correct. That is, emitter should be connected in series in a circuit and current to be measured flow through it. कितना current flow होते ना उतना पूर्ण current हमको. What is this one? अभी विजिबल है क्या? आंसर भी दिखाया मैंने. Which of the following materials will be prepared as a shunt for extending the range of measurement of a voltmeter here? To extend the range of voltmeter, okay, voltmeter range extend करने के लिए prepared as shunt for the prepared as a shunt बोले. Okay, shunt for extending the range of measurement of voltmeter or emitter, whatever it may be. To extend the range, we have to add some resistance. We have to add that material of that resistance should be copper, steel, aluminum, and manganese. Which one is the correct answer? अभी explain किए उसमें mention भी किया था मैंने. Have explained and even have used the word of that. Yes. Is it audible or not? All of you are sitting silently.
Audible sir.
Then give the answer, na?
सर पता नहीं.
पता नहीं is not a answer. There is no option at all. है क्या उधर ऑप्शन है क्या? पता नहीं बोल के कौन बोल रहे हैं पता नहीं बोल के? आंसर देखो, मैग्नेट बोल के है इधर, डिस्प्ले हो गए ऑलरेडी. Okay, so many questions are there. I will upload this PPT in the your teaching diary, whatever the created by Viresar, your CC. You can read that one. Okay, so many questions are there. Answers also I have given here. Still so much syllabus is also I have added. Nearly 165 slides are there. So these questions only are around 60 questions I have added here. You can read all the questions, and the bridges and potentiometer. Bridges also very important. Huh? Don't forget that one, bridges. Whitson bridge is there. Whitson bridge is used for the low resistance, high resistance, and medium resistance. Which one?
Medium.
Medium. Whitson bridge is a AC bridge or DC bridge?
DC bridge.
DC. Then what are the AC bridges then?
Maxwell's bridge.
Okay, very good, very good, very good. So the bridges are mainly classified into two types: AC bridges and DC bridges. First, to measure actually the three circuit elements are there: resistance, inductance, and capacitance. To measure the resistance, we are going to use the DC bridges here now. So DC bridges, there are two bridges are there: Whitson bridge and Kelvin double bridge. And the AC bridges are again classified for the based on the parameters we are going to use. If the inductance we are going to measure and capacitance we are going to measure here now. If we are going to measure the inductance, then Maxwell bridge is there, Hayes bridge is there, Owens bridge is there, Anderson bridge is there. For the capacitance, we are going to use D-Sauty, Sering, and Wayne's bridge. We are going to use for the bridges here now. Use for the measurement of capacitance, resistance, inductance. We are going to use different types of bridges. We are going to use all the bridge derivations. You have to remember the formula. The balanced equation for the bridge is balanced means if it is R1 equal to R2 R3 divided by R4, R1 का place में. So if R equal to SP divided by, sorry, what is that? P equal to RS divided by Q we can use, or by using this formula you can any order you can change that one. PS equal to QR you can also use that one. So P equal to QR by S or R equal to PS by Q, like that we can arrange the equation here. So Kelvin double bridge is used for the low measurement, low resistance, high resistance, medium resistance. Which one? Kelvin double bridge. Kelvin double bridge is used for the measurement of low resistance or high resistance or medium resistance. Very good, very good. Means bridges का already दो बार repeat हो गए, इसके लिए perfect हो गए आप लोग. ऐसा लग रहा है मेरे को. Okay, इधर भी questions है. So both questions I have added some MC questions, even I have explained also. You read it well, and the ATT class will stop here only. I will share the test. कितने बजे को है? 3:30 or 3 o'clock? You have to conduct the test, na? 3 to 3:30, I think. Yes. I don't know. I will check that one, and I will put the link in the WhatsApp group. Okay. So we'll stop here only for the ATT class. Just a minute.